Hey everyone, welcome back. I'm Alex.
And I'm Ben. And Alex, I am so glad you're here because I am completely stuck. I'm trying to map out a new feature, and honestly, it's a total mess. You know how it is. A customer does something which kicks off a server process, which then has to go check a database. I keep losing track of what happens when. It's like trying to follow a conversation where everyone is talking over each other.
Yeah, that's exactly it. How do you visualize that? Because every time I try to just, write it all down, I end up with this massive wall of text that nobody, including me, can actually follow. What I need is a blueprint, something visual that actually shows the step-by-step flow.
Okay, Ben, you have literally just described the perfect use case for what we're talking about today, the UML Sequence Diagram. Seriously, think of it like a comic strip for your system's logic. It shows every single interaction as it happens, one frame at a time.
Right. And the key thing to get here is that it's a type of behavioral diagram. So what does that mean? It means we're not focused on the static parts of your system, like what it is, we're focused on what it does. It's all about the dynamic behavior, the action from one moment to the next. It's a map of the conversation, the sequence of messages flying back and forth between all the different parts.
And that's really what makes it so powerful. Its whole job is to model that flow of logic. What's cool is that time literally flows from the top of the diagram straight down to the bottom, so you can just follow it with your finger and watch the whole sequence of events unfold. And the best part? This helps you spot check and validate your logic before anyone writes a single line of code. It gets everyone on the team looking at the exact same picture of how a feature is supposed to work.
Okay, I am 100% sold. That sounds like exactly what I need right now.
Awesome. So before we jump in and actually build one for your problem, let's really quickly break down the main parts. Once you know these basic building blocks, reading them and making them becomes totally second nature. It's pretty simple, actually.
Okay, first thing you'll see are the objects, or sometimes called actors. These are basically the who or what in the conversation. They're shown as little boxes right across the top of the diagram. So this could be a user, a server, a database, really anything that can send or receive a message.
All right, I see those. And what about those dashed lines that drop down from each box? Does that show how long that object is, alive during this whole interaction?
You got it. That's exactly it. It's called a lifeline, and it represents that object's existence for the entire time we're looking at this specific sequence.
Okay, next up, you'll see these skinny little rectangles that appear on the lifelines. Those are called activation boxes. All they do is show you when an object is busy, like when it's actively processing something or doing some work. It's just a super clear visual way to see who's doing what at any given moment. And last, but definitely not least, this is probably the most important part, are the messages themselves. These are the horizontal arrows that go back and forth between the lifelines. Each arrow represents a specific communication, like a function call or a request for data. This is really the heart of the diagram. It's the actual conversation we're trying to map out. All right, so now we know all the pieces. Let's actually put them together and see how it works in the real world. We're going to use a super common and simple example from our source material, just a customer placing an order on a shopping website. So let's start really simple. We've got just two participants here, the customer, who's our actor, and the server, which represents the website system. You can see they each have their own lifeline, just waiting for the interaction to start. Okay, I see. So that first arrow, that's the trigger for everything else. The customer is sending a place order message directly to the server. The arrow points right from the customer to the system, making it obvious who's initiating the action. Exactly right. But now, the server can't just take the customer's word for it. It needs to check if that item is actually in stock. So it sends its own message, verify product, over to a third participant that we've just added to the diagram, the database. Hang on, I see that the arrow coming back is a dashed line, not a solid one. What's the difference? What does that signify? That's a great question and a really important detail. A solid line is usually a command or a call to action, but a dashed line, like this one, represents a reply. It's the return of information. So here, the database is simply responding to the server, letting it know, yep, the product is available.
And now that the server has that confirmation, it can finally complete the loop. It sends one last reply, a dashed line for confirm order, back to the customer. And just like that, the whole sequence is complete. See how clean that is? It lays out the entire flow from start to finish.
Okay, that makes perfect sense. It's super clear. But that's the happy path, right? That's when everything goes perfectly. What happens when things go wrong? Like, what if the product is out of stock?
That is such an essential question. And it brings us to another huge strength of sequence diagrams. They are fantastic for mapping out those alternative flows and exceptions.
Okay, let's just put them side by side. On the left, we have the successful scenario we just walked through. But check out the right side, the exception case. The first two steps are exactly the same, but look at step 3. This time, the database replies with not available.
And wow, that one change completely alters the end of the story. Instead of getting an order confirmation, the server now has to send a totally different message back to the customer telling them the product isn't available. Seeing them next to each other makes it so easy to visualize the different outcomes.
You know what? I totally get it now. This isn't just some random drawing. It's literally a blueprint for how a piece of software is supposed to behave in a real-world situation.
That is the absolute perfect way to describe it, Ben. So let's just quickly summarize why this is also important, because these diagrams are a game changer for anyone building software.
So, number 1, you get to validate your logic. You can literally see potential gaps or problems in the flow way before you waste time writing code. 2, it's amazing documentation. Anybody, technical or not, can look at this diagram and get what's supposed to happen. And 3, and this might be the biggest one, it just massively improves team communication. Everyone's working from the same visual playbook.
Yeah, and this quote from our source material really hammers that point home. It says a sequence diagram enables the software architect to both document and validate the logic during the analysis and design stages. The keywords there are analysis and design. This is a forward-looking tool to help you build things right the first time. It's all about being proactive, not just reacting to problems later.
So, here's a little something to think about. The next time you tap a button on your favorite app, just pause for a second. Think about what hidden conversations are happening behind the screen. What messages are being sent? Which systems are talking to each other? You now have the mental tool to visualize that entire hidden dance.
That's so cool. It really makes you think.
It really does. Well, thanks so much for joining us for this explainer.